Hello everyone, I hope you all are doing fine. In the previous class, we had learnt about the scalar multiplication and its properties, and also we had done one example of multiplication. If you haven't watched that video, I recommend you to go and check that. In the previous class, I had given you a problem to solve. I hope you did it correctly. Let me solve that problem for you first, and after that we will move to our today's topic. So here is the matrix, and it was asked to identify if this matrix is a idempotent or involuntary or none of them. So let's solve this. Okay, as we know, for any matrix considered to be as idempotent, they need to satisfy the following equation, that is a square equals to a, and for an involuntary it should satisfy a square equals to I. So to check, we have to find a square first. A square can be written as A dot A, which means we have to multiply A matrix to the A matrix to get the desired result. Okay, so let me write the matrix here. A square equals to A dot A equals to minus 5 minus 8 0 3 5 0 1 2 minus 1. Next, minus 5 minus 8 0 3 5 0 1 2 minus 1. Let's do the multiplication. For first element, we'll go along the first row of the pre-multiplier matrix and first column of post-multiplier matrix. So here it is. Minus 5 will give us 25. Minus 8 plus 3 will give us minus 24. And 0, 1 will give us 0. Minus 5 minus 8 will give us plus 40. Minus 8, 5 will give us minus 40. 0, 2 will give us 0. Minus 5, 0 will give us 0. Minus 8, 0 will give us 0. And 0, 0, 0. 3 minus 5 will give minus 15. 5, 3 will give plus 15. 0, 1 will give 0. 3 minus 8 will give 24, that is minus, and 5 will give 25. 0, 2 will give 0. 3, 0 will give 0. 5, 0 will give 0. And 0, 1 minus 1 will give 0. 1 minus 5 will give minus 5. 2, 3 will give 6. And minus 1 will give minus 1. 1 minus 8 will give minus 8. 2, 5 will give plus 10. And minus 1, 2 will give minus 2. 1, 0 will give 0. 2, 0 will give 0. And minus 1 will give 1. Okay, let me write here as answer. 25 minus 24, 1. 40 minus 40, 0. 0. Minus 15 plus 15, 0. 25 minus 24 is 1, again 0. 6 minus 5 plus 1 minus 1, 0. This 10 minus 10, 0 and 1. So we can see that the resultant matrix is an identity matrix. So this option is correct, which means the matrix A is an involutory matrix. Okay, let's move to the new topic, which is transpose. Transpose helps in solving for the matrix inverse, and it also helps in finding the variances and covariances. In regression. Not visible. In regression. We represent transpose by symbol capital A and capital T in the superscript. Okay. In transpose, suppose there is a matrix A which is represented by A, small aij. Here aij represents the element of matrix A. Then A transpose will consist of elements A, J, I. You can see here that I, J and J, I, the position of the element changes, or we can say reverses. Here I reverse changes to J and J changes to I. So let's understand this by example. Let's take a matrix A where I write as 1, 2, 3, 4, 5, 6, 7, 8 as elements. Let's find out transpose of this matrix A. A transpose. As I told you, Aij changes to Aj. Here A11. So it will be A11 same, so value will be 1. Next it is 1, 2, so it will change to A21. So 21 position is this one. This one is 1, 3, it will change to 3, 1, and this one is 1, 4, so it will change to 4, 1. This one is 2, 1, it will change to 1, 2. Next 6, 7, 8, same. You can see here the order is 2 by 4 and order of this transpose is 4 by 2. So the order reverses when we do a transpose of a matrix. Now we'll study about the properties of transpose. Okay. properties. First property is transpose of a transpose will give the original matrix. You can see here by example, if I choose 1, 2, 3, 4 and I transpose this one, will give 1, 2, 3, 4, and again if I transpose this matrix, it will give 1, 3, 2, 4. You can see that the double transpose gives the original matrix. So we understand the first property. Let's go to the second property. Second property is transpose of summation result of two matrices can be given by the transpose of second property, which says transpose of the sum of two matrices can be given by the sum of transpose of these two matrices. Condition is that these two matrices A and B is of same order. Okay, so let's understand this property by an example. Assume a matrix A 1, 2, 3, 4, matrix B 5, 6, 7, 8. Let's find the transpose of matrix A. 1, 2, 3, 4. Transpose of matrix B 5, 6, 7, 8. Okay, let's sum these two. 6, 10, 10, sorry, this is 8 and 4, 12, and let's sum these two. It will give 6, 8, 10, 12. Let's transpose this one. 6, 8, 10, 12. As you can see here, this matrix and this matrix both are same. It is 12. So this property is valid. Okay. Let's go for the third property. Third property we have K of A transpose equals K A transpose. Let's verify this property by an example. Let's say suppose a K2, a scalar value, and A, a matrix of 2 by 2, 2, 4, 6, 8. Okay, this is 2 by 2 matrix. Let's find the first LHS. will have 2 times of 8, which will be 2 2s are 4, 2 4s are 8, 2 6s are 12, and 2 8s is 16. Now we have to find the transpose, which will give 4, 8, 12, 16. Okay. Now let's find the RHS. First we have to find the A transpose. So A transpose will be 2, 4, 6, 8. Then we have to multiply K. So K A transpose, which will give 2 2s are 4, 2 6s are 12, 2 4s are 8, and 2 8s are 16. You can see here that RHS equals to LHS. So this property works. Okay. Let's go to the fourth property. Fourth property is A B whole transpose equals B transpose into A transpose. Let's understand this property by an example. Assume a matrix A 2, 4, 6, 8 and a B matrix 3, 6, 8, 5. Let's multiply both of 2. A and B will give 2 3s are 6 plus 4 8s are 32. 2 6 is 12 plus 4 5 are 20. Next 18 plus 64. Next 36 plus 40. And the result will give 38, 32, 82, and this will give 76. Let's transpose this one. This will give 38, 32, 82, 76. Let's find the other side, RHS. For that we have to find the B transpose. So B transpose will be 3, 6, 8, 5. A transpose will be 2, 4, 6, 8. Let's multiply both of these. B transpose into A transpose will give 3 2s are 6 plus 8 4s are 32. Next element will give 3 6 are 18 plus 8 8s are 64. Next element will give 6 into 2 12 plus 5 into 4 20. Next 6 into 6 36 and 5 into 8 40. Let's solve for this. We'll get 6 38, this one 82, this one 32, and this one 76. You can see here that both LHS and RHS are equal. So this property is verified and workable. Okay, let's move on. Our new topic is symmetric matrix. Symmetric matrix. We have learned how to find the transpose, and one property of transpose when follows A matrix equals to A transpose, then we will call this matrix as symmetric matrix. Okay. For example, if there is any matrix 3 minus 1 1 minus 1 2 5 1 5 minus 2, let's find the transpose of this matrix. A transpose is 3 minus 1 1 minus 1 2 5 1 5 minus 2. So you can see here both transpose and A matrix both are equal, which means this matrix is a symmetric matrix. Okay. There's another matrix which called skew-symmetric matrix. Skew-symmetric. In skew-symmetric matrix, our matrix A is equals to the negative of A transpose. Then we will call it as skew-symmetric matrix. For example, let's assume A matrix 0 2 iota 3 minus 2 iota 0 4 minus 3 minus 4 and 0, and find the transpose A transpose, which will give 0 2 iota 3 minus 2 iota 0 4 next minus 3 minus 4 0. Now as we can see both are not equal. Let's take out minus 1 from this matrix. It will be minus 1 and it will be 0 2 iota 3 minus 2 iota 0 4 minus 3 minus 4 and 0. Now you can see that both A matrix and minus of A transpose is same. So this matrix represents a skew-symmetric matrix. Okay. Let's move to the new topic. Okay. Let me tell you a theorem here which states that every square matrix can be expressed uniquely as the sum of symmetric and skew-symmetric matrix. So a square matrix can be expressed uniquely as the sum of symmetric and skew-symmetric matrix. can be represented as matrix A, which is square matrix. Here A is a symmetric matrix plus another A which is skew-symmetric. Okay, that's all for today. In the next class we will learn about minor, cofactors, then determinants, and example problem for them. Okay, I hope you did understand today's topic, and if there is any doubt, please comment. And thank you.